Welcome back, Hyperbolic Coding Chamber participants. This is day 21 or day 22, actually day 22 of LeetCode every day. Make sure to join the Discord, Hyperbolic Coding Chamber. There are thousands upon thousands of hundreds of thousands of people in the Discord. If you're thinking about shutting Discord down, I'm talking with the people at Discord. We're going to try and make another one to make sure we can fit everyone in. But yesterday we did LRU Cache. We also fried a number of islands, so I just added that to the problem algorithm. So we just added a new problem, number of islands. We did LRU Cache yesterday, also fried some other problems. And then, yeah, I started with LRU Cache. We started doing anything. I think the intuition behind the problem was correct, but the way we were going about just doing the problem itself was incorrect. I should have did the problem today, but since I ended the recording so quickly yesterday, it turns out I'm actually going to start the first maybe 20 minutes actually doing an analysis as to why this code does not work, and then we'll do the regular work where we do we'll check the cards. We'll check the cards. So we have one problem here, intersection of two linked lists. I feel like I can already taste the algorithm, so we'll do this problem here. And then we'll probably do some random weighted. We'll do one weighted random weighted problem, and then we'll do a new problem, and then we'll just choose the next one on the LeetCode list. So hopefully we have enough time to do a few problems. Maybe we'll actually do 2 hours today, to be honest. But so we'll probably do, maybe we'll do an hour and a half, maybe 2 hours today. We shall see. So again, some more mediums under the belt. Some other things to note. The last, merge intervals, I just added to the list, so I have to do that again whenever the algorithm decides that we should do it. But the top LeetCode problems, so we can't try LRU Cache today. So I'm going to inspect as to why we didn't work the first time. So maybe we'll do median of two sorted arrays. This is apparently a hard. Seems to be very frequent. So maybe at this point we should just start sorting by difficulty. And just do one medium, then one hard, one medium, one hard. Or honestly, just do all mediums at this point. Yeah, that might be the wave. Or actually just more by frequency. But yeah, we need to cover way more distance. Ideally, I mean, we're just gonna have to do 20 minutes of problem, look at the solution, and go to the next problem. Hopefully by this time it will be ingrained. But gonna jump into it. Other things to note. So I actually don't know which one we're gonna do next. We'll just figure it out. Maybe we'll probably just do, yeah, if we do by frequency, I mean, I think doing by frequency, it makes the most amount of sense. That people see them in actual interviews but I think it also makes sense. I think they have like the curated 75 or something like that. That maybe would have been a better idea, but I'm sure most of these problems are already included in there, so maybe it doesn't matter. That being said, the last video, day 20, got 260 views, so that's pretty hype. I'm pretty sure it's being view botted, but we'll see. Good comments as usual. I also noticed some older comments from some videos about how to actually fix some solutions in terms of other LeetCode problems. So I'm thinking that I've also been slacking on making videos for new problems. So maybe we'll try and do a weekly one on that. But technically every day is a new day where we teach a problem. So it is what it is. But I'm just going to jump into it. A little preamble as usual. Make sure to join the Hyperbolic Coding Chamber Discord for all the secret tips and tricks that Copy Ninja is dropping pretty regularly. At the same time, if you have a better way to do this problem, or if I run into any nonsense and you think you know the solution, feel free to include your solution as well. At the same time, if you're also doing daily LeetCode as well, you might as well drop a comment. So yes, So I'm just going to jump into it. 1 hour and 30 minutes. If we feel better afterwards, we'll keep going. But we'll start with the usual warm-up problems. So the intersection of two linked lists, time complexity of O of n plus m with a constant space complexity. So we have get intersection node, and we have head A, head B, and we have to return a list node. Standard definition for a singly linked list: given the heads of two singly linked lists, head A and head B, return the node at which the two lists intersect. The two lists have no intersection at all, return null. For example, the following two linked lists begin to intersect at node C1. So we have two linked lists, and they'd like us to return the node at which they intersect. Test case generators, there are no cycles anywhere in the entire linked structure. That's important because the algorithm I'm thinking of working doesn't work without that. So we have two linked lists here, and it looks like the intersected node is 8. And here the intersect node is 2. Final example where we have no intersection, we should return null. So it seems that there's one way we could solve this, and that is a way in which, if we take a look at the sum of the length, take a look at the length of both of these linked lists, you can see that they share 3 nodes, which means that if we take a look at just the length of the linked lists themselves before the intersection, we'll have 2 and 3. That would be 5 and 6 respectively. And if we do 5 minus 6, which would be the length of A minus B, and take the absolute value of it, we could see that there would be only 1 node difference between these two linked lists. From that point, we could just sequentially iterate and check for identity. So it seems like the secret sauce is actually making the run length up until the intersection point the same distance. And then we can check for identity. So what we'll do is we'll make run length the same, then check identity. There's also another way we can do it where we can just have them both run across each other and then changing to A and B respectively. But so we'll just make the pseudocode. So to make the run length the same, we'd have to count the length of A, right? Count length of B, and then move longest up by abs of longest minus shortest. And then from here, we could just do if we want to check identity sequentially, we could just iterate while they both exist. If node 1 equals node 2, return node 1. Right? If we get to the end, if we ever get to null and they never equaled each other, we'll return null as in no intersection. So to do that, we have to count the length of A. So we'll create a temporary pointer which we'll set to head A, and we'll have len or const len A, which will start at 0. To count the length of A, we'll just do it the standard way. While temp does not equal null, we'll do len A plus equal 1, which means this should actually be let, and then we'll do temp equals temp dot next. We'll reuse temp, copy this to calculate the length of B, and then we'll also set temp equal to head B to reset where it's at, and we'll do len B plus equals 1. So now we need to do the longest up by the absolute value of the longest minus the shortest. To do that, we would actually have to figure out which one's the longest and which one's the shortest. We can do that by checking the value of the lengths that we just found. So if length A is greater than length B, it must be that head A is the longest, otherwise it's head B. How do we tell which one is the shortest? It would be whichever one is not the longest, right? So if head A equals longest, then the shortest must be head B, otherwise it must be head A. And then we just have to check identity sequentially. So we'll iterate while longest and shortest exist. And it's a little small down here. Maybe I'll make it a little bit bigger. We'll just say if longest equals shortest, then we're going to return longest or shortest. They would be the same here, so it doesn't matter. We'll do longest equals longest dot next, and shortest equals shortest dot next. And so that looks good. So we can double check to make sure it works here with this list here. We'd have len a equals 0, temp equals head a, so we look equal to head a. While temp does not equal null, so a is not null. We'd have 1, a is not null again, we'd have 2, a is not null again, we'd have 3, a is not null again, we'd have 4, a is not null again, we'd have 5. So length of 5, we check this one, so len b would be equal to 0, temp would equal to head b. Temp does not equal null. And since it's not null, we'd count 6, right? And so this is what we forgot to do. We have to move the longest up by the absolute value of the longest minus the shortest. So we skipped a step. So we want to do for let I equals 0. I is less than math absolute value of len a minus len b. I plus plus with the longest equals longest dot next. And we should be safe here since longest is longest. So we should be able to move it up safely. And so we have 5 and 6. So longest would actually be head B. Shortest would actually be head A. And then we move longest up 1 point. And then we check while they both exist. Do they equal each other? No. So we'd go next to both of them. Do they equal each other again? No. They would on this iteration, so we'd return longest. Otherwise we'd return null. I always forget that both of these equal lets. So that first one looks good. So that looks good. So what is our time complexity? Well, we have to iterate over both the length A and the length B. So I'm going to say the time complexity is going to be bounded by the length of both lists A and B. So I'd say it's time complexity of A plus B with the space complexity that is constant since we're just using references to new nodes. So that looks good. We'll reset the timer and we'll go to a random weighted problem. Start the timer again. It looks like we have binary tree in order traversal. Oops, looking at the solution, but it's okay. We already knew the solution. So you have in order traversal. We have a root tree node, and we have to return an array of numbers. So given the root of a binary tree, return the in order traversal of its nodes. In order traversal just means the relative ordering among the left between the nodes in a binary tree, which would be the node itself, its left subtree and its right subtree. In order refers to the order in which the order would be L and R. So the L and R would be an order traversal of this node's value. So we start at 1. We go left, left would be null, so then we'd go. Oh, and the way we're returning the in order traversal of the node's values with an array of numbers. So right, we'd do n, which would be none, which would be 1. Then we'd go right. Once we go right, we trigger another call this function, so we'd go left. Once we get to this one, we'd go left again. We'd go null, we'd pop this off, add 3 to the array, right, go right, that would be null. We'd pop this call off the stack, go back to this null node in which we'd do n, which would be 2, so 1, 3, 2, and then we would have the in order traversal, we'd have one more call, which would be null, This would be inconsequential since the right subtree would be null. So to do this with recursion, we could create a array that we're going to return called nums, and we'll have a function helper in which we pass in the root and also this array of numbers. This helper function would take a tree node or null, and we would take nums, which would be this array of numbers that we're using by reference. We actually don't want to return anything since we're going to be handling this by reference. We want to make sure the node exists because we want to actually exclude null values, but if we didn't, we would actually still exclude this if statement here. So we would have this helper function that we actually misspelled. So if the node exists, like we said, L and R, the node traversal is just the relative ordering of an L and an R. So we call helper with node.left, passing in nums. We'd actually just do a processing step, which we would just push the current node's value onto the array. We would have helper node.write nums. We don't have to return anything, so we'll do a test run. We'll create this empty array. We'll have helper, which is a root, passing in the root node, and the number array, which is going to be modified by reference. So we're starting with 1. The node does exist, so we're going to push a call of helper onto the call stack and go left. It's going to be null. We have an if statement, so we're going to skip to the end, right? Then we're going to pop that off the stack with null, go back to 1. We're going to push 1 onto the array, push a call of helper onto the stack with 2. We're going to be here, we're going to push a call of helper onto the stack with left, push another call of helper onto the stack with null. It's going to be null, so we're not going to return anything. We're going to do the processing step for 3. We're going to push 3 onto the stack, then do write, which is going to be null, pop that off the stack, push 2 onto the stack, and do write of 2, which is null, and we should be done. So that looks good. The time complexity would be linear time, with the space complexity being, in the worst case, linear time, because the node could, the binary tree could be linear in the sense that it's just a bunch of nodes connected. No, it would just be linear time because you have to visit every node anyway for the binary, the LNR traversal. So number of nodes in the range up to 0 to 100, so root can be null. And the values was negative 100 to 100. Recursive solution is trivial. Could you do it iteratively? You could do it iteratively, and it's going to look similar, sort of. We're going to use a stack here, and we still have this numbers array. We're going to have a cur node, which allows us to keep track of where we are, but also go left as far right as we can, because this would be LNR, right? We'll have a double inner while loop, so we'll say while cur does not equal null or stack.length does not equal 0, right? Then we're going to want to say while cur does not equal null, right? We're going to want to push our current node onto the stack, right, and go left, right? Because we want to go as far left as we can. And once we can't go far left anymore, we're going to know that our current node is null. Since our current node is null, we're going to exit this loop and actually end up here where we're going to want to do cur equals stack dot pop. So it will be right before the null portion. So we're going to want to process there. We're going to do nums dot push cur dot val, and then do cur equals cur dot write. If we run that real quick, we'll have a stack nums and cur. Well, cur is equal to root, so it's not null, and the stack doesn't matter because cur isn't null. So we're going to short circuit and jump into it. Cur isn't null. We're going to push 1 onto the stack. Cur is going to equal cur dot left, which is going to be null. So we're going to exit this. We're going to pop 1 off the stack. So we're going to be 1 again. We're going to push 1 onto the array. Then we're going to go right. Cur won't be null, and the stack won't be empty either. Actually, the stack is empty. Cur won't be null in here, so then we're going to do stack.push 2, And then we're going to do cur equals cur.left. So we're going to go left. We're going to push 3 onto the stack. Go left again. We're going to be null. We're going to exit out here. So we're going to pop off the stack and get 3. Push 3 on to the array. Then go right, which is going to be null. Which is going to be null up here, but the stack won't be empty. We're going to be null here. So we're going to pop 2 off the stack. Push 2 onto the array. Then go right, which is going to be null. We're going to go to the top. Cur is going to be null, and the stack will be empty. So we want to return nums. So the iterative solution looks good, but I think the space is technically 2n. Oh yeah, the space is linear space as well, since we're going to have to push basically every node into the stack at some point, which means we declare a stack that does indeed take up to linear space where n is the number of nodes in the binary tree. So past this one, I'm going to do a 20 or an analysis on LRU Cache since we did it yesterday, but I didn't get to see why it doesn't work. So maybe I'll try and fix this. Another higher level point is to note that I forgot to declare a function for these move to front and return basically there's a linked list and a map, and the doubly linked list we have to remove nodes and add nodes pretty frequently. I didn't create a function for it, so I ended up having to duplicate a bunch of code, which is just bad practice. In the future I should just make a function so that's easier to reuse. It was actually harder to copy the code, so I'm not sure why I did that. But this is a mess. I'm just going to remove all the pseudocode. Capacity. So we get the constructor. We have the max capacity. We set it equal to capacity. And then we want to wire up head and tail. So this dot head dot next equals tail, and this dot tail dot prev equals head, which makes sense. If we get the key, if the map has the key, right, then we want to move the current node right to the end of the linked list. That way we can, when we remove elements, when we pass capacity, we have to evict the least recently used key. We can do it from the front of the linked list. So move it to the end of the linked list. Could have made a function called class function called move to end, and it'll take a node, should be a dlist node. It can't be null, and it's void, so it doesn't return anything. So is this how you would move if we had a doubly linked list, like 1 goes to 2 and 2 goes back to 1? Let's just say we had H and tail. So I would look if you had a node, dlist node, we'd say this dot tail dot prev. I don't know why we need this. Oh, we want to move it to the end. So this dot tail dot prev would equal 1, and then the node dot next would equal this dot tail, this dot tail dot pre, right, and this temp dot next would have to equal the node, but we didn't fix where we currently were at, I think, which is what breaks the linked list. So basically, if I do this dot tail dot pre, so this dot tail dot pre equals node, this dot tail dot pre equals node. So pointing back to it, we have dot tail dot prev, this dot tail dot prev. So we do have this arrow pointing back to 1 here, and then we have node dot next equals this dot tail. So we end up pointing back the tail here, and then temp dot next equals node, which equals 1. But we never fix what's going on up here. So there's another thing we need to do, is basically, maybe it's the first thing we do, fix where node was. So you need to reline these pointers up here. So you can say temp2 equals node dot next, temp3 equals node dot prev, and I guess what you really want to do is temp3 dot next equals, or I guess you could just do node dot prev dot next equals node dot next. So node dot prev, so 1 dot previous dot next actually wants equal to node dot next, which would be 2, and then node dot next dot previous we actually want to equal node dot previous. And so basically everywhere we were doing this move to end nonsense, so what about when we create a node, we move it to the end. Yeah, this is still a mess. Probably shouldn't have deleted the pseudocode. Move to end. I'll run it again just to YOLO it, but no reading next. Right, so when it actually doesn't exist, it's kind of nutty. If node dot previous right, so I think we just need to see how they did this, because the solution was just wonky. Standard version of the article published on the discussed forum. Problem can be solved with a hash map that keeps track of the keys and its values in a double linked list that results in constant time for put. And get operation allows us to remove the first add node in constant time as well. So you have a head and a tail node and the keys and the values. We also have a map that allows us to instantly get to the node in the linked list. Double linked list that the node can remove itself without other references. True. Addition takes a constant time to add and remove nodes from the head or tail. Particularity about double linked lists implemented here is that there are pseudo head and pseudo tail to mark the boundaries, that we don't need to check null during the update. So look at the Python solution. So we have self.key. I should have kept my original submission. Dang. So capacity to capacity. So they're not even using max capacity. So if key not in self, return -1. And I think what I did, oh, so they did create a move to end, right? So when you do a get, if it doesn't just return -1, otherwise move the key to the end and then return the key. So we had that. If key in self, if key is in self, when they put the key, right, move the key to the end and just update the value. Otherwise, if len of self, I see, you could always just check the size of the, right, so add a current capacity, but since we're using a map, you could always just check the number of elements in the map. So here we're using an ordered dict, so let's just check the hash map plus double linked list. This one's more involved, so they have key, which is 0, value, which is 0, and prev and next. Oh, this is a double linked node, so a link. So then they're also keeping track of the key and the value in the node. We always add the new node right after the head. So to do that, if you want to add a node, we do node dot prev equals self dot head, node dot next equals self dot head dot next, and then we'll say the head dot next dot previous equals node, and this self head dot next head dot next dot previous equals the new node we're adding, and self dot head dot next equals the node. So there's two things. We have to link up the nodes pointers, the new nodes previous to head, and the new nodes next to where the wherever was pointing at head dot next. And then we have to make sure that head dot next is pointing to head dot next dot previous, right, that the previous node that was the right after is now being pointed to the new node, and that the head dot next equals the new node. I really should have kept the previous code. Yeah, I think it's gone. They had add node and remove node to remove an existing node from the list. We were also missing that functionality. So given a node, would say prev equals node.prev and new equals node.next. Then we'd, what is the new node here? New equals node.next. So to make sure, so we would just say prev equals node.prev and new equals node.next. And you would just say prev.next equals new, new.prev equals prev. Start a node in between to the head. Since we add the node at the head, you can just remove the node and re-add it in the linked list since it adds it to the front. Pop tail, we can just pop the current tail res equals self.tail.prev, and then we'll just do self.remove node res, and you can just return res. So they'd have the cache, the size, the capacity. So cache, size, capacity equals capacity, self.head equals self.tail. You can also just keep track of the map size. So they also kept a literal size property, and they keep a node to head and tail, and they set up the connection to head and tail. So we did do that. When you get the node, you check if it's in the cache, and if it's not, then you return -1. Otherwise, we would access node to the head. And then we do a type. We check if it's in the, they're using an object, but I think it's just a map. You check if it's in the map. If it is, update the value, node.value equals value, self.move to head. If it's not, you create a new node, create a new key for the node, new value with the node. You add the key, add the node to the map, then we add the node, which should be added to the front. So it's I plus 1. If we go over the capacity, we want to pop the tail and decrease that. So we had it right. I think our pointer situation was very ghetto. So it's interesting what you can do with add. Oh, not this implementation. Interesting what you can do with add and remove node. So if we remove a node, then add the node, we're adding it to the, moving it to the front, because we always add a node to the front. Doubling list allows us to remove a node just with one reference to the node. Interesting. Yeah, we'll try this one tomorrow. We did this one. So then I'll try a new problem. I'll reset the timer. LRU Cache. Let's try a median of 2 sorted arrays, which is a hard. We have function find. We have function find median sorted arrays. We have nums1, which is an array of numbers. We have nums2, which is an array of numbers, and we have returning a number. Given 2 sorted arrays, nums1 and nums2, of size m and n respectively. M and n aren't given to us, but we can tell by the length. Return the median of the 2 sorted arrays. Overall runtime complexity should be log of m plus n. So it looks like they want us to do some sort of binary search over both. So we have 1, 3, and 2. Since they're sorted, merged array equals 1, 2, 3, and median is 2. So we have 1, 2, 3, 4. The merged array is 1, 2, 3, 4. The median is 2 plus 3. It's 2.5. So it looks like we can have it to 1,000 elements in the array. Overall runtime complexity should be O log of m plus n. So O log of m plus n. So if we merge the arrays, that would be m plus n. If we merge arrays, that would be m plus n sort the merged array, that would be log of m plus n if len of merged mod 2 equals 0. So if it's divisible by 2, which means it'd be even, we would just take the center. So we do 4 divided by 2, which would be index 0, 1, and 2. And the index before that, those 2 divided by 2 would be 1. So we take these two indices, return merge sub merge len over 2 plus merge submerge len over 2 minus 1 divided by 2. Otherwise, we could just do, if we have 3 elements, we'll do 3 divided by 2, which would be 1.5. We floor that, then we'll just take 2. Otherwise, return merge submerge len over 2 floored. So we take a look at this. So it looks like both elements can be empty. In the case where they're both empty, not sure we should return. Oh no, it looks like there's always at least one element in both of them. So we just merge them. So for 1 and 3, we'd have 1, 3, and 2, right? We'd merge the arrays, that'd be m plus n, sort them, and then if len of merge mod 2 would give us 3, so we'd do return the merge, the floor of merge len over 2, which would be 1.5, floor would be 1, which would be 2. If we do it for this one, we'd merge the array, that'd be 1, 2, 3, 4. Sort them 1, 2, 3, 4, and then mod 2 would give us 0. So you return the merge of the center point and the center point minus 1. It would be 4 over 2. So we take merge of index 1 and 2, so 0, 1, and 2, which would be 5. And return that. So this looks like it works. Let's try and implement it. Merge looks like nums1, nums2, sort AB minus B. So this is one line for both of these up here. And then we'll say if merge dot length mod 2 equals 0, then we'll return merged. Center would be the merge dot length over 2. Floored it, so we can't subscript an array with a non-integer value. So you have merged sub center plus merged sub center minus 1 over 2. Otherwise, we do center over 2. The answer is undefined. So I'm wondering if I messed this part up here. I'm gonna print merged Oh no, so this looks good. We got 1, 2, 3. Center equals the math.floor of merge.length, which would be 3 over 2, which would be 1.5. Floor would be 1. Merge.length mod 2 equals 0. It doesn't, so we'd return, oh, not over 2. We just return the center point. This looks good. Looks like the time complexity of log of m plus n if you merge the arrays. I guess, yeah, I mean, it's m plus n when you merge the, oh, the whole thing must run in log of m plus n. Log of m plus n. So if you merge them, it'd be m plus n. So we'd actually be bounded by the length of the arrays. So we actually can't do this. Yeah, actually no, yeah, we're off, because if you were to sort this merged array, it wouldn't be log of m plus n, it would be m plus n log m plus n. So maybe you could do this with a double 2-point. Either way, there has to be some kind of binary search aspect. Could do a binary search. You do a binary search. Overall runtime complexity should be log of m plus n. Do any algorithm that log of m plus n would be search is n log n. So binary search wouldn't work. Log means we have to be having this somehow. Merged equals none, so 1 common none. Thumbs up length equals m, and thumbs up to that length equals n. 0 less than m, less than 1000, less than 1000. So how do you go about solving this? Log of m plus overall runtime complexity. Merging it would be m plus n, and sorting it would be is log of m plus n overall time complexity. Should be log of m plus n. Is log of m plus n better than, is log of m plus n, is log of m plus n better than log of m plus n better than, if we merge the arrays, that would be m plus n. Sort that would be log m plus n log m plus n. Log of m plus n. Since they're both sorted, we don't know if the sort, how the sort ends up working out. The median is the number in the center of, the median is the number in the center. I think they got me on this one. It says there's no solution for this question. It looks so binary search. I mean, it looks like there is some binary search aspect to this. If you fuse them, you have m plus n. You can't fuse them if you get to do m plus n, log m plus n, you can't fuse them because fusing them would be m plus n. So you have to be able to do a binary search on both since they're sorted. Binary search on both, on the median. Which is faster than merging the two arrays. O of log m plus O plus log of n. This person merges it. Yeah, they do the same thing I do here. Was asking performed in brute force manner using a combination of above functionalities. This person is also sorting them. Everyone seems to be sorting it. This looks like a problem where you have to see how close you can get. Two arrays and merge them into a third merge sort, then pick the median element. N log n. I don't think this is n log n. I guess creating a third array would be m plus n. But if you just extend one of the arrays, it could be log of n. I think that's just semantics, since you still have to sort it, which would technically be m plus n, log m plus n. Has to be between 10 to the 6 and to 10 to the 6. Do a binary search of the same both arrays. So L equals n plus m is even. No, half index. Lowest, the median. So our low is less than high and median not found. Highest plus lowest over 2. Jeez. So just go to the next one. Let's try trapping rainwater. Restart the timer. So we have function trap, and we have height, which is an array of numbers, and we have to return a number given n non-negative integers. So this is the array of numbers representing an elevation map where the width of each bar is 1. Read how much water it can trap after raining. So all the numbers in n and number are all positive, and integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap after raining. So I think this looks like a black section is represented by array. In this case, 16 of rainwater, blue section are being trapped. It's not showing why. Oh, maybe because it's not doesn't have a buddy to close it in. Sample 2 4 2 0 3 2 5. So if we have 4 high, 2 high, 0, and then 3 high, so we can visualize this as we have 2 high, nothing here. Then we have 3 high, 2 high, 1, 2, 3, 4, 5, and they're saying it is 1, 2, 3, 4, 5, 6, 7, 8. I'm not seeing where the 9 is. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much rain can trap. So maybe we'll use star for water. Or we'll use dashes for water. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically, between these 4 and 4, it seems like summing up the numbers between the lowest height or the highest height shared doesn't work because we'd have 2 plus 3 is 5 plus 2 is 7. We'd still be missing. So it looks like maybe we want to do that, but for each distance. So we go between 4 and 4. Maybe we recurse again and we sum the two between here. Any zeros get substituted for the second highest value between them. So we have 2 and 2 here. We have 2 plus 3 . So maybe it looks like water exists if there is a number that is less than water exists if water exists when does the water exist? It looks like water exists when the value between two numbers, so this would be 1 and 2, when the value that we're currently at meets a non-zero value when curve value finds value that is less than, so 1 goes to 0, goes to 2, where the current value is less than 2, is less than the current value. So we'd have 1 going to 1, and it can't be greater than it, is less than or equal to the current height. Oh no, it's greater than or equal to current height. So if we find a value like 1, we try to find a value that's greater than or equal to 1. We do, which is 2, but the distance between them means we can only have 1 water. Then we keep going forward. We have 2, and we try to find a value that's greater than. So we have 1, 0, 1, 3. That's greater than or equal to 2. So now we have to calculate the water for a range. So I think we could do this with 2 functions. Could iterate over number array, find a bucket, you could find buckets, or for each we would, so we start at 0, try to find the bucket end. Basically we're trying to find, for each number we want to find a bucket range and calculate the water for a bucket range. Find bucket range, water for a bucket range. How do we find a bucket range? We start with 0. Number has to be greater than 1, greater than or equal to 1. If num greater than or equal to 1. Then we found a bucket start. Maybe for this number we'll try to find a bucket end. Less greater than or equal to 1. Find bucket end. We find the bucket end, then calculate water for bucket range starting from num going from num to bucket end, and then num equals bucket end. So I think we could try implementing this. We would say let start equals 0. We'd iterate while start is less than height. Right, then we have start plus equal 1. So if we set num equal to bucket end here, after calculating the bucket range, we'd set it equal to 0, 1, 2, 0, 1, 2, 3. We set it equal to 3. So we'll do bucket end minus 1. So here we just have to find the bucket range. So if height sub num is greater than or equal to 1 means we have potential for water. If we have potential for water, then we could call a function called find, well, we'll just do find bucket end, which is gonna have we'll just say while a new thing called temp, which will be equal to num we'll say while t is less than height and height sub num. So how do we find a bucket end? We find a bucket end when we find a number that is greater than or equal to our current number. And height sub t is greater than or equal to height sub num, or is less, oh, so we want this to go while t is less than height, so we start at 1, right? And 1 is less than 9, and height sub t, which is 1, is so we'd start at 2. So height sub t, which is 2, which would be 0, is less than height sub num. Then we want to do t plus equal and plus equal 1. So now we have the bucket end. Now you want to calculate the water for a bucket range. So we'll have let water equals 0, water plus equal, and a function called calc water, where passing height, passing start, we'll pass in end. At the end we will return water. A function up here called calc water, which will take an array of numbers, we'll pass in the start, which will be a number, and an end, which will be a number, and it's going to return a number. It's going to start at 0. And it's going to return water, so we're going to be at this range of 1 and 2. Height sub end, which is 0, is less than height sub num, which is 1. 2 is not less than that, so we do 1 and 2. So how do we calculate that? You could say if they're different heights, oh, we can't just subtract it actually. Maybe we could count every number. Let's just say we had these two. Maybe we could count. We had 0, 1, 2, 3, going to 4, 5, 6, 7. So 3 to 7. 1, 2, 3 to 7, which would be here. Maybe we could do. So we have to know our max height. If our max height is 2, if anything is greater than or equal to 2, then it gets discounted. So we could just subtract everything minus our max height, basically. We have a const maxed height. How do we calculate our maxed height? And it's basically the math dot min of height sub start or height sub end. That would be 2, and we would just do for let I equals start is less than end. Oops, yeah. I is less than end. I plus plus. You just say water plus equal max height, which would be 2 minus height sub I, which you would get starting from 2. 2 minus 2 is 0. 2 minus 1 is 1, so water plus equals 1. 2 minus 0 is 2. 2 minus 1 is 1. So we only want to consider the positive values. Equals max height minus height I. Value greater than 0. And we'll add it to it. Otherwise, we'll add 0. So I'll delete the pseudocode 2 minutes. And I'll run it with a test. Run it with a test case, something like this one. So we have height should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have a range going from 0 to 11. Our start is 0, water is 0, so we'll say while start is less than height dot length. Start is 0 while start, so 0 is less than 11, right? So say if height sub num sub 0 is greater than or equal to 1, 0 is not greater than or equal to 1, so we go to the next iteration. Is 1 greater than or equal to 1? It is, so end is going to equal to num plus 1, which is technically going to be 2. Since e is going to be equal to 2, say while end is less than height dot length, so 2 is still less than 11, and height sub end, which is 0, is less than height sub num, which is 1. It is, so we do n plus equals 1, so it equal 3 now. While n less than height dot length. So 3 is less than height dot length. Height sub n 0, 1, 2, 3 is less than height sub num. 2 is not less than 1, so we'd stop. Then we do water. So 0, 1, 2, 3. So we do calc water for height going to between 0 and 3. So that would be 0. So we ran out of time, but math.height of min of basically 1 or 2. So it's going to be 1. Max height is going to be 1. And so I is going to start at 1 while I is less than you want it. We actually don't have to include the end. So I is going to equal to 1 and n is going to equal to 3. So max height value, so max height, which is 1 minus height sub I. So water plus equals 0 because value would be 0. I plus 1, so then I equals 2 now. Max height, which is 1 minus height sub I, which is 0, would be 1. So we would add that to water and go out, and we'd skip, so we'd return 1 here. We turn water. Then our bucket end, which was 3, 0, 1, 0, 1, 2, 3. Yeah, we do start equals bucket end minus 1, just because we don't want to do another start plus equals 1. So we do start plus equals 1, we get 3 again. If height sub num is greater than 1, or 1, which it is, it would be 2. Then n would equal num plus 1, so n would equal 3, which makes sense. Well, no. Wait. So height sub num, this should be height sub start. It's greater than or equal to 1. This would be bucket end minus 1. Should be, so it would be 2, 0, 1, 2. Then we, so height sub start, which would be 3, n would equal to num plus 1. N is less than height dot length. Then we want to calculate this. So 3 is less than 11, and height sub n would be less than height sub. So we'd be calculating between the range 0, 1, 2, 3, and 5, 6, 7. So 3 and 7. So is this right? So our max height would either be 2 or 3. So our max height, not our max height, what we actually want is our min height, which would be 2. Then we iterate over the range and pretty much subtract the value, which is the number of blocks. To the min height, so we have 1, 2, we have 4 basically. So I think this makes sense, so we'll run it. I have to delete this. Okay, so let's start. It's just some stuff left over from the pseudocode. So we're off by 1. I'm wondering why that could be. Maybe if we add one to our end, get the right answer, but not certain if we could. Right, so it looks like we're close. We have a small problem. If we do this one, our output here is 10. And I feel like it has to do with the end. Here we get an extra 1 even though we shouldn't. Should have an end. Maybe we only want to add, when do we want to run calc water? Maybe only when one is 4. Let's try with a smaller input size. So it looks like the problem that we're having doesn't happen with this, so maybe it has to do with an extra one that we're supposed to ignore. So maybe I return 1 extra than I need to here. Okay, so it's not in the front, it looks to be in the end. Okay. Never mind. Off by 1. Say if start does not equal end, then calculate the water. So we're still off by 1. Maybe we should include the end, but to be honest, I'm just guessing. Oh man, I messed up. It seems to be, problem's a bit hard to visualize. A bit hard to visualize height equals 0. height 0, 1, 0, 1. So the water here would be 1 block, that'd be 1. You'd have 1, and then 1, that'd be 2, 4, 5. And the only thing left would be 2, 1, 2. So our end is less than height dot length. Height sub end is less than height subs. Two is not less than 2. So we keep going. And 2 is less than 2 is not less than 2, so you wouldn't keep going. And which is 1? Is 1 less than 2? It is, so we keep going. Is 2 less than 2? It's not. So start doesn't equal end. Water plus equal calc water. That'll be 2. I would start at 2. I is less than end. So min height, which would be 2 minus height sub I, which would be 2, so value plus equals 0. And then min height, which would be 2 minus height sub I, which would be 1. Water plus equals output is 1, 5. Add water to it, it's 1. We add water to it, it's 5. And we add to it, it's 0. Doesn't make sense because it should be 1, 5, 5. We get 5. We try console, paste this in here. So we actually get 140. So we call it 3 times. It's probably between here we get 1, between here we get 4. Makes sense. But this final one, we calculate it again. Maybe we'll print also what started it. So we'll print height sub start. So 1 started this one, which makes sense. Four started this, no, 2 started this one, which we get 4. And then 3 started this one. restarted this one. Oh, I think it start is not equal. And we just want to keep going as usual. We don't want to skip it. Only if we calculate it do we want to skip. So we came to 3. So 2 should have triggered 1 though. Oh, no. I think it's actually like this. If we calculated water that was greater than 0, then we want to skip. We don't want to recalculate because we already skipped it. Okay, so 4, 2, 3 output is 0, but it should be 1. Height sub start. So I'll just print when we do trigger a calculation. Should be four, 2, and 3. So so I think there's one more case we can add, and it's while height is less than end, we'd like to keep height sub end is less than start. Or height sub and height sub end 4, 2, 3. So I think with this test case, we said it's not that simple. You can't just choose the one that's smallest, the one that's smaller than height sub end minus. So we have height sub start, which is 4. We can't just choose the one that's less than that. I mean, keep incrementing end. Let's just see what it calculates for end. So for 0, we got 3 as an end. It actually should be fine. If we got 0, 1, 2. We got 0 for that. So I think our solution is insufficient. I'm going to read the solution off recording.